All right, we're looking at P12a. Now, the goal of this video is to find the zeros of polynomial functions from factored form. So there's two big things here that we really have to learn. The first one is what in the world is the factored form of a polynomial function? And then the second thing is what in the world is a zero? And at that point, we're going to be able to figure out how to find the zeros of the polynomial function. So I want you to recall that the standard form is what you're used to. So it's going to look like something like f of x equals, and then it has a bunch of terms, right? So it could look like something like x to the fifth minus 3x squared plus 2x minus 1, right? So a polynomial in standard form has several terms, or could just be one, but it has terms, and we look at the degree here. Now, the degree of this one is the largest exponent, right? And that's fun, and that's easy to tell just by looking at it. Now let's take a look at factored form. So factored form is going to look like f of x equals, and then it's going to say like x minus a, x minus b, c, so on. Right, A, B, and C, those are going to be numbers, right? So there'll be numbers in there. I'm just saying in general, factored form looks like this, where you can see each individual factor. Now, let's take a look. What's the key difference that you see between standard form and factored form? Well, the standard form, it's all written out and has individual terms. Factored form, the big key difference here, factored form has parentheses, right? I could see these parentheses here where we're multiplying these different terms together, and if we were to multiply all these out, we would end up with standard form, right? So here this is factored form and this is standard form. Now, how could I tell the degree from factored form? How can I find the degree in factored form? Well, I would have to count the number of factors, and if there were exponents on a factor, I would add up all the exponents of the factors. So, for example, if I had f of x equals x minus 1/2, x plus 6, x minus 12. Okay, so how many factors do I have? Well, I have 1, 2, 3 factors. So if you could imagine was multiplying all this out over and over and go multiply everything out, we would end up with x to the third power. So the degree here would be 3. Another example here real quick. If I have something like f of x equals, let's say x plus 2 squared, like that, and x minus 1, I don't know, x plus 3, and let's say x minus 5, and let's give that one a square as well. So what this really says is x plus 2 squared, so x plus 2, x plus 2, x minus 1, x minus 3, x minus 5, and x minus 5, because there's 2 of them. So there's 2 here, 3, 4, 5, 6. So the degree of this one would be 6. Okay? So that's something to keep your eye out on, something to kind of pay attention to. And now let's get to the meat and potatoes of what this video is really all about. Okay. A zero of a polynomial. Zero of a polynomial function it is defined as, so the zero of a polynomial function, it is x values for which f of x equals 0. And that's it. So I'm going to replace f of x with 0 and then solve the polynomial to find the x values that make the y value 0. Those are called the zeros of a polynomial function. So you're going to hear me use the word zeros quite a bit. And every time I say, well, what's the zero of this polynomial function? Just remember that's when f of x equals 0. Okay? Now let's practice a couple of these. All right, so let's take a look. What happens, for example, if I have f of x equals x plus 2 times x minus 4, x plus 1. All right, so the degree, just to remind ourselves, the degree here is going to be 3, and that's okay. Don't need to write that down. Don't need to do anything here as far as the degree is concerned. But what I need to do is find the zeros. So the directions for a problem like this are going to say, find all zeros of the polynomial function. All right, so the directions that you're going to get are going to say, find all the zeros of the polynomial function. All right, well, here's the polynomial function in factored form. And for a second here, off on the side, I want you to recall the zero product property. The zero product property. Remember, if I have something times something equals 0, then either A equals 0 or B equals 0, right? If I have two things or more multiplied together to equal 0, then each one of those factors are going to equal 0. All right, so back to the problem here. If I have to find the zeros of the polynomial function, well, f of x equals 0. So I'm going to say 0 equals x plus 2 times x minus 4 times x plus 1. And now if I think about my zero product property, if one of these things equals 0, so like let's say this first one equals 0. Well, 0 times this times that would equal 0, right? 0 times anything equals 0. So I'm going to take the first factor, x plus 2, and set that equal to 0. And then I'm going to set the next one, x minus 4 equal to 0, and x plus 1 equal to 0. And now I solve each one. Minus 2, so x equals negative 2. Plus 4, so x equals 4. Minus 1, so x equals negative 1. All right, and that's it. These are my zeros. And I want to take just a little second. I want to think about something. What was the degree? We said the degree here was 3, right? How many answers or how many zeros did we end up with? Let's take a look at it. I wonder if that pattern is going to continue as we go along. All right, so now let's take a look at another example in factored form that might give us a little bit of grief. Okay. So there's two factors here that look a little bit different than the others, right? And I really want to pay attention to these. I could easily say, okay, so x plus 4, let's go look at the end. X plus 4, obviously that's 1. X minus 5 is another one. 3x plus 1 is another obvious factor. But what about this guy right here, just x, right? This is yet another factor. So here we have 1, 2, 3, 4 factors, right? So just a hint, a reminder to ourselves, the degree here is 4, so I hope at the end I end up with 4 answers. All right, so each factor, if we follow our zero product property, right? Zero product property, set each factor equal to 0, then we're going to solve. So here, the first one is going to be x equals 0. Right? This first factor is x. Set that equal to 0. Well, there's nothing left to solve here, so I'm done. And then I'm going to say 3x plus 1 equals 0, x minus 5 equals 0, and x plus 4 equals 0. And subtract 1. 3x is going to equal negative 1. Divide by 3. And x equals negative 1/3. Over here we add 5. So x would equal 5. Here we subtract 4. And x would equal negative 4. Right, and that's it. That's as far as I have to take it. I have found all of the zeros. Here in a little bit, we're going to go backwards. On P12b, we're going to go backwards. So let's pay close attention to how we would go backwards in a situation like this. This was a fraction, right? And that fraction had a number in front of x. So pay attention to a couple of the weird ones, because on P12b, we're going to go backwards.